Now we are going to read some theorem after that problem. First one, let x be a rational number. Rational number is of the form p by q, no? So let x be a some number whose decimal expansion terminates. Whose decimal expansion terminates means 6.25. That is terminate. There is no cap, 2 point cap, 3.3 cap, not like that. It terminated. It's stopped. Then x can be expressed in the form p by q. That is numerator and denominator 1 by 2, 1 by 7 like that. Where p and q, if terminated, this is terminator, this is non-terminated. We can write p and q are co-prime, that is there is no common divisor, and the prime factorization of q is of the form 2 power n 5 power m, where n, m are non-negative integers. So idea is simple. If it's terminated 6.5 means we can write p by q form. If it's terminated means definitely this q is of the form, that is denominator is of the form 2 power n into 5 power n, where n and m some integer, that is 2 power 2, 5 power 3, 2 power 1 into 5 power 4, like that we have form. So this is the meaning of the theorem 1.5. If it terminated, then the denominator is of the form 2 power n, only 2 power n 5 power, not other than this 2 and 5. That is 3, 7, 11, not other than this 3, this 2 number. So this is the meaning of this theorem. So that is suppose 11 divided by, suppose the 207. After finding the prime factorization of this number, so 11 divided by some number, for example 110 given, no? So 110 we can write 11 into 2 into 5. Denominator you have 2 and 5, but other than this 2 and 5, 11, no? So definitely 11 now we can cancel. After that this number 1 divided by 2 into 5, that is 1 by 10. This is the terminating expansion. But 13 divided by 110. So 13 divided by 11 into 2 into 5. Now denominator other than 2 and 5 we have 11. So definitely this is non-terminating. That is other than 2 and 5 you have some number. So if it terminates, that q only 2 power n 5 power n form. This is the meaning of this theorem, right? Next theorem. Let x equal to p by q be a rational number such that the prime factorization of q is of the form. The same rational number, the prime factorization of q is of the form 2 power n 5 power n, very non-negative integer. Then x has a decimal expansion which terminates. So rational number, the reverse case of this one, the previous theorem. Rational number such that prime factorization of q, just prime factorization of this q, we solved, no, q is of the form only 2 power n 5 power n, not other than this, where n, n are non-negative. Then x has a decimal expansion which terminates. Terminates means it stops. First one, rational number, decimal expansion terminates, that is 1.5, like that it's terminate, implies p by q form, where q is only 2 power n 5 power n. This is the first theorem. Second theorem says that if it's p by q form and q 2 power n 5 power form, then that answer is 1.5. That is p implies q, that is q implies b. This is the meaning of the second theorem. So we can tell this is the converse part of the first theorem. So number terminate, then q only 2 power n 5 power n form. Then next theorem, then q denominator 2 power n 5 power m, then the number is terminate. That's all, right? Next one, let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 power n 5 power m, where n, m non-negative integer. Then x has a decimal expansion which is non-terminating, repeating. X equal to p by q such that the prime factorization of q is not of the form. Not of the form, no, other than this, not other than this 2 power n, we discussed, no, 11, 13, like their number 2. Instead of 2 and 5 we have some other number, not a multiple of 2 and 5. means we can tell this is non-repeating, that is recurring decimal expansion. For that, first problem, without actually performing the long division method, state terminating or non-terminating decimal expansion. What do you want to check the denominator factors. Only 2 and 5 means we can tell it's terminated. Other than 2 and 5 we have prime factor, then we can tell it's non-terminated. That's all. So using method. So what is meant by long division method? This 13 3125, divide this 13 by 315. This is long division method. Don't do for this problem, right? Now 13 divided by 3125. Here the prime factorization of 3125 is 5 power 5. So here we have 5 power 5, no. So just we can write 2 power 0, 2 power 0 1, 2 power 0 into 5 power 5. No need to write this 2 power 0. Anyway, other than 5 and 2, no other number, no, this piece. So we can tell this is the terminating decimal expansion. That is of the form 2 power n 5 power m, where n equal to 0 and m equal to 5 power. So which is terminating decimal expansion. Other than 2 and 5 you have some number, means we need to tell the non-terminating decimal expansion, right? Now 17 by 8, 17 by 2 power 3. So automatically we can write this step, no, which is of the form 2 power n 5 power n. So it is a terminating decimal expansion. We need to write by this step. 64 divided by 455. The prime factorization of 455 is 5 into 7 into 13. Only 5, but extra 7 and 13, no, other prime numbers you have. So it's here we need to write which is not of the form 2 power n 5 power m. We need to write like that. This is not of the form 2 power n into 5 power n. So therefore it is non-terminating repeating, right? Next, 15 divided by 1600. The prime factorization of 1600 is 2 power 6 into 5 power 2. So only 2 and 5 base, no. So we can tell it's a terminating decimal expansion. Next number, 29 divided by 343. 29 divided by 7 power 3. We can tell the things other than 2 and 5 we have number. Not only 2 and 5, here we have 7, no. So we can tell the answer. This is not of the form 2 power n 5 power n, so it is non-terminating repeating decimal expansion. Now 23 divided by 2 power 3 into 5 square, as it is given 2 power n 5 power m, by using that first expansion we can write. So you need to answer by this only, we need to write all the one. So it's terminating. Now 129 divided by 2 square 5 power 7, 7 power 5 given. So other than this 2 and 5 base we have 7 also. So 7 power 5 we have, so it's non-terminating repeating decimal answer. Before that you need to write this is not of the form 2 power n 5 power n. And 6 divided by 15. Now think about the numerator 6, denominator factor 3 and 5. You can cancel this 3. We need to write the simplest form. After that only you need to decide. After cancelling this 3, you have 2 by 5. Now 2 by 5, only factor 5, no, it's terminated. Like that. So you have any number in numerator, denominator, a common number means cancel. After that, okay, denominator other than 2 and 5 we have number or not. Using this, right? If you have a common factor in numerator and denominator, cancel, then write your answer. At 3550 you can cancel by 5, no, so 7 by 10. Now write your answer 7 by 2 into 5. Okay, that is terminating decimal expansion. 77 by 210, cancel by 7 first, or we can write the thing is 77 divided by 21, no. So 2 into 5 into 2 into 5, that is 210 plus 2 105, next 3 remaining 1 5, next 5 7, 2357, 2357, here 77, like that means 2 3 5 7. Now cancel by 7, so 11, no, so that is 11 divided by 2 into 3 into 5. Now we have 3 also. After cancelling this also we have 3, not possible to cancel this 3, so it's non-terminating decimal expansion. Next problem, the problem is given. Suppose it's terminated, tell them the number of decimal. So for that, don't go the long division method, we are going to use the idea 10. So here 13 divided by 2 into 5 power 5, already discussed this. So now our aim is our power term should be equal, then only 2 into 5 10, 2 squared into 5 squared, that is 2 into 5 the whole square, that is 10 squared. 2 power 3 into 5 power 3 equal to 2 into 5 whole power 3, that is 10 power 3. Now if in denominator 10 square 10 power 3 means we can write our decimal easily. That's why we need to write the same power. For that, check which one is the lowest power, which one is the biggest power, then multiply the biggest power term and form the biggest power form, that is 5 power 5 into 2 power 5. We need to multiply, no, because this is 1, we need to multiply 2 power 5 numerator and denominator. No need to multiply this because we can write 5 into 2 whole power 5, so that is 10 power 5. Denominator, on all the problem write denominator like that, but numerator expand. 2 power 5 value it's 32. Now 13 into 32 value 416. 10 power 5, now 10 power 5, no, now 1 2 3 4 5 like that, 0.00416. Now this is the answer. So how many decimal? 1 2 3 4 5, so 5 decimal. Like that, write your answer, right? Next, second problem, 17 divided by 2 power 3. For that we need 5, no, so just multiply the here 3 power 3, so power 3 form, so 5 into 3, 5 power 3 multiply. Here convert 2 into 5 10 to 10 power 3, but numerator convert your 5 power 3 as 125. So 17 into 125 value, so 2125 divided by 10 power 3. Now we can put our decimal is, no, so 3 decimal. Using the denominator we can write 2.125. Next, 15 divided by 2 power 6 into 5 power 2, like that we need to write. Third problem, it's non-terminated. Now fourth problem, 15 divided by here power 6, here power 2, so that multiply by 5 power 4, then only 2 plus 4 6, so multiply by 5 power 4 in numerator denominator. So that's why check the power term, then convert the equal power form. For that we need to use 4, so change this 2, no, here we use 4, right? Now 15 into 5 power 4 value 625, here 2 power 6 into 5 power 6, so 2 into 5 10 power 6, multiply 15 into 625 9375, so 6 decimal 1 2 3 4 5 6, so 6 decimal, this is the answer. Next, fifth problem, the same way, 23 divided by 2 power 3 into 5 power 2, power 3 and power 2. So here we need one more 5, then only 5 power 1, so 5 into 5 we need to multiply. So 23 into 5 115, but here 5 power 3 we can write, so 2 power 3 into 5 power 3, so 115 divided by 10 power 3. Now 10 power 3, no, 3 decimal, so 0.115, like that, right? Next, 2 by 5 it's directly given, we need to multiply 2 in denominator because 5 is alone, we need a same power, no, so 5 power 1, this is the meaning, so here multiply by 2 numerator denominator, so 2 into 2 4, 5 2 are 10. Now it's 0.4. Next problem, 7 divided by 2 into 5, 2 into 5 both are same, no, so no need to write. 7 divided by 2 5 both are same power, no need to multiply anything, so 10, 7 by 10 value 0.7, so like that, write only which problem you have a terminated expansion, write the decimal, this is the problem. So question 1 2 4 5 8 and 9 alone terminating, remaining alone non-terminating, right? Next problem, Suppose this is the problem 43.1235. So no cap, no dotted. So definitely it's terminated. If it's terminated by theorem, you can write you have a p by q of this decimal. No, decimal implies rational form. Decimal no, so that is terminated. So definitely it's of the form. It's a rational number, and in p by q terminating decimal expansion. Q is of the form in p by q, that is the p by q form of this number terminating decimal expansor. So q is of the form 2 power n 5 power m. Terminated no, right, by theorem. So actually theorem whose decimal expansion terminate. Here we have decimal expansion terminate. Then p by q form. P by q form. We need to write this theorem directly. Then p by q or pq are co-prime, and the prime factorization of q is of the form 2 power n 5 power m. So if the given number is a rational number whose decimal exponent terminates, therefore in the p by q form, q, the prime factorization of q is of the form 2 power n 5 power n. Like that we need to write the answer. Next hint only I am given here. Next here 1 2 0 1 2 1 1 0 1 1 2 0 0 1 2 4 0, like that. It's non repeated anything, and also it's goes on. So such a types it's called irrational number. So it is not of the form p by q. It's not of the form p by q. Next one, cap given. So repeating, anyway it's of the form rational number, but we have terminated means definitely q only 2 power n 5 power m, but it's repeated means other than 2 and 5 we have some factor. So q is of the form 2 power n 1 or other than 2 power n 5 power n form. So there is the theorem. Let p be a rational number such that prime factorization of q is not of the form 2 power n, where n come a non-negative integer, then x has a decimal expansion which is non-terminating repeating. So that's why it's non-terminating repeating. It's non-terminating repeating, no. So in b by q not of the form 2 power n 5 power m. Like that we need to not of the form 2 power n 5 power m. This is the answer. Thank you.